Welcome to Programming News. It is August 22, 2026, and today we are looking at a pivotal moment for the Rust ecosystem. We are seeing a massive technical leap in the language's core architecture, contrasted against a serious security warning regarding malicious crates targeting the supply chain. First, the Rust compiler is making a fundamental shift. The next-generation trait solver has been enabled by default on the nightly channel. This is being described by the development team as the largest single change to the compiler since its initial release. To understand why this matters, you have to look at how the compiler handles logic. This rework replaces the way the compiler proves where, clauses, and normalizes associated types. It is essentially a foundational overhaul that serves as a necessary prerequisite for upcoming features like return type notation and type alias impl trait. The impact on existing code is widespread. The new solver addresses over 200 known issues currently tracked on GitHub and has already shown significant improvements in type inference for complex scenarios, such as those found in the Bevy and Mini-Ginger crates. However, this kind of architectural evolution rarely comes without growing pains. While some crates are seeing massive performance gains, for instance, the datafusion crate is reportedly compiling more than 8 times faster, others have experienced significant regressions, with some compilation times becoming quadratically or even exponentially slower. If you are running the nightly channel, there is a second practical hurdle to prepare for: the error messages. The team has noted that they have not yet prioritized refining the error diagnostics for this new component, so you may encounter confusing or unhelpful feedback when the compiler hits a snag. There are also concerns that the new logic might change how opaque types are handled. Because of these variables, the Rust team is encouraging developers to test their existing projects on nightly now to catch any bugs or performance regressions before they become part of a stable workflow. While the compiler team works on these long-term improvements, the Rust security response team is dealing with a more immediate threat. They have verified a supply chain attack involving several malicious crates designed to deliver payloads through build scripts. The compromised crates include proc macro 1, proc macro n, Aovine, Aroni, Aranenio, and TinyMember. One of the most notable names involved is the arrayref crate. In this case, the security team believes the author's account or computer was compromised rather than the author acting maliciously. The attacker was able to republish versions of arrayref that depended on malicious crates, effectively hijacking the dependency tree. As a precaution, the author's account has been locked and several affected versions of arrayref, append-only vec, and internment have been yanked or deleted from the registry. For developers, the immediate takeaway is a call for manual auditing. The security team advises that you should check your local cargo registry cache to ensure these malicious versions haven't already been pulled into your local environments. Whether you are testing the new nightly compiler to see if your build times improve or auditing your local cache to ensure your dependencies are secure, the message from the ecosystem today is clear. The tools we rely on are evolving at an incredible pace, and that evolution requires a heightened sense of vigilance.